are going towards this because it is not always possible to say if something is true or not true, right? Sometimes we say, okay, this is the chance that it will going to be true. For example, if I say that it will rain tomorrow, I cannot say it will rain or it will not. I can say, okay, this is the probability or this is the chance that tomorrow it will rain. So it means that it is very important for an AI agent not to work on monotonic logics, mean true or false, not on a certain logic. If there is an uncertainty, it should have the capability to work on that. So that's why we going to go through the probability, and hopefully in the probability we will go up to Bayesian's network. So some of the logic you will find familiar, but still we will go over it. So this is the same thing that I've just said, that normally you say yes or no to something. Even in case of human, you say some reasoning, and maybe sometime next time that reasoning is incorrect, but based on certain information you say, okay, this is some information, and then maybe later on you say, no, this wasn't true. It means that your solution would be based on knowledge in a given frame of time, right? So that's why we want to make a solution where you are able to make decisions based on uncertainties. So like I said, that not every problem in the world is true or false. We cannot say that. But sometimes we can say that, okay, this percent of chances that this is going to happen. So that's why it is very important for an agent to work under uncertainties. If he knows certain facts, but if he's not very certain, he should be able to work on that. And if he say that if there was certain, if in everything is if there was a definite certainty, no one would ever have acted on anything. If I say, okay, I will not go outside. If I am going outside, maybe I will hit by a car. So I will never go outside. So it means that your agent should not be only based on certain information. So if we talk about uncertainty, it is something being in a state of unknowing or being in a state of uncertain. So if for example it's Tuesday, what is weather on Wednesday, what is weather on Friday, then you do some analysis, probably forecasting. Maybe we will see if we're going to cover Markov chain, which do predict future. Similarly, if you talk about a dice, so in this case, you don't know, you cannot say that now the next thing that will come is 1. However, I can say that the chances that 1 will come is this much. So how we quantify these things? These things are basically quantified by probability. And again, why is there is an uncertainty? There are many reasons. One reason can be you don't have enough information that can bring you to certain information. For example, weather can change, it's unpredictable. Or there can be uncertainty because that we did not consider all the possible options. It means that because maybe we were more lazy, or in some cases we ignored some of theoretical knowledge, or it wasn't possible. So that's why it means that to cater with all these things, it's very important that we bring probability into our decision making so that we can make decision in case we are uncertain about something. Now, what is probability? We all know that probability is what are the chances that something would happen, likelihood of happening something. Probability is always between 0 and 1. It cannot be greater than 1. Now, if you look at the formula, it says that probability of an event is number of instances of the event divided by total instances. So if, for example, you think of a dice, so I know that in a dice, 1 can appear only 1 time. And what are the total possible options? 1 can come, 2 can come, 3, 4, 5, 6. So it means that total there are 6 possibilities and 1 can come only one time. Similarly, if I talk about 2, again 2 will come only one time, but there are possibilities there were 6 possibilities out of which 2 can come only one time. So it means that this is how we find probability. Again, it is written here, probability doesn't mean an event is true or if it is occurring. It means that it is possible that there are chances that it will occur. And again, like I said, that probability of any event would always be between 0 and 1. But if you combine all the events, it would all sum to 1. For example, probability of coming 1, coming 2, 3, 4, 5, 6. So it is 1 by 6, 1 by 6, 1 by 6, 1 by 6. So if I sum them all, it would be 1. So it means that for all the events, if you add up the probabilities, it would come to 1. By the way, you came on the right time, the time we were starting the new lecture here. Okay, so now, as I said that if you talk about the dice, you can see that for all of them, the probability is 1 by 6. It's same. Why it's same? Because it is a fair dice. If for example on a dice you have 2 times 1, mean one is on 2 sides, then it is a kind of unfair dice, right? Then it could be 2 by 5 because there are 5 possibilities and 1 can come 2 times. So in this case, if I say what is probability of getting 6, it would be 1 by 6.
Before I come, I was working on my probability, that's why I came on time less.
Okay. Okay, now if you move a bit further, and if we say that, let's say we have 2 dice, right? If we have 2 dice, and now how much previously we were having six possible options, right? Either 1, 2, 3, 4, 5, 6.
Possible options, right?
How much options?
So you have
No. 6 times 36. Right? Because, for example, 1, 2, 3, 4, 5, 6. So if on this is 1, then it is possible that on the other is 1 or 2 or 3 or 4 or 5 or 6.
That's how neural network works, doesn't it? Different. Again,
No. Yeah. So similarly, if you have 2 here, again it is possible that on the other it was 1, on the other it was 2, 3. So in this way, you get overall 6 cross 6, 36 possibilities. So here you can see that it is possible that on the first dice it was 1, on the second it was 1, then on the first it was 1, then 2, 3, 4, 5, 6, then 2 started and the second was, and so on. So you will get 36 options in this case. So you can see that the total possible options in this case are 36. Right. So if I write them in terms of numbers, now you can see that if someone asks you that what is the probability that the sum of the dice is 2? What is the probability that sum of dice is 2? So you can see clearly that 2 is coming only one time, and your total number of your total outcomes are total possibilities is 36. So I can see that for 2 it's 1 by 36 because 2 comes only one time. Similarly, if I want to look for 7, you can see that 1, 2, 3, 4, 5, 6. So probability that sum of 2 dice would be 7, it's 6 by 36. If you go towards 12, what would be the probability? 1 over 36, right? Very good. And if you go for 4,
3.
so you can see that it's 3, so you get 3 by 6 and so. So this probability, the probability that we just saw was unconditional. It means that we just say that we are rolling dice. There was no previous information.
It's a luck, isn't it?
Sorry?
Yeah,
it's luck, yes. But if for example I say that if one of the dice has 6, what is the probability that the sum of 2 would be 12? So now in this case you can see that now I have put a condition that if I know an information that one of the dice would give you 6 for some reason, I knew the information, I knew the evidence. What is the probability now that the 2 will give you 12? The sum of 2 would give you 12. So it means that whatever we have seen previously, those were unconditional probabilities. There were no information. If we were just rolling the dice and was getting some unexpected thing. But there are possibilities that where you would relate something. For example, you will say that what is the probability that if it is cloud, what is the probability that it will rain if it is cloudy? What is the probability that if it is not rain, if it is not cloudy?
It would be 50-50, right? If we got 50% of it already, so
No, if no, this is not true because okay, if you know that what is the probability of rain? Rain could depend on different things, whether it is sunny, whether it is cloudy, whether it is a normal weather,
Time,
or yes, time. So it is not always possible.
season, maybe.
but we're also saying we got the cloud there.
So what is it? So it
But
is not possible.
it's not the only factor.
Isn't it
Yeah.
a factor? Yeah.
So if it is cloudy, you cannot say it is 50-50.
Okay.
Yeah, it can be that if, for example, I see cloudy, there are some other factors, I can say, okay, it will rain, and considering that it's cloud, it is 0.2, let's say. We will
Yeah.
see it in a while.
Yeah.
So that's why we say that we need to bring conditional probability into action. For example, in this case, you can see that what is probability that it will rain today, given that it rained yesterday. Similarly, what is the probability that I will change route based on traffic condition? Okay. This is something which would depend on traffic at that amount of time. The probability of traffic at that time, it will affect me. Similarly, what is the probability that you have the disease given the test results? If you just say disease, it would be different. If you say disease given test results, it would be different. So how do we define conditional probability? We say that probability of A is true given B is equals to probability of A and B divided by probability of B. So in this case, you can see that if you want to know whether A is true, A would happen given B is true. What would be the probability? It would be probability of their AND happening them together divided by the probability of B. So this is how we would define the conditional probability. Now coming to the same example that we have just done, we are saying that what is the probability that the sum would be 12 given that one of the dice we already know is 6. So if you say 1 is 6, what is the probability that you would get 12? So in this case, now coming to the formula. The formula says that you need to find two things in the formula. One is AND probability, both of them happening together, and then the probability of B. So let's find the probability of B. Now you see we are saying probability of B. So when finding probability of B, we will forget about the A given B. It's only what is the probability of getting 6. So 1 by 6. If you look at the green, so you can see that probability of is 1 by 6. So it means that we have solved the denominator part. Now A and B. So it means that now we need to see that we get sum 12 when it is B.
1 by
So-
6 times 1 by 6.
So which condition out of this all palette will give you 12 when you have 6? You get 12 and one of them is 6. Can I get 12 here? No. So one of them is 6. So this is 6, right? This is 6. So can I get 12 from here? No, right? So it means that the only option that I can get 12 and one of them is 6 is this one. Right? So it means that what would be the end probability of this?
1 by 36.
1 by 36. Because this is the only possible case where one of them is 6 and I can get the sum equals to 12. So it means that this is the only possible case where. So it means that if I want to see P sum to 12 and one of it is 6, we will get it 1 by 36. We'll see later on that the conditional probability is very important, because if we know something, we can backtrack the other thing, and vice versa. So it means that now we have both informations. We know the probability of B, we also know that what is probability of getting 12 and B. So it means that I will put it here, it's 1 by 36 and it's 1 by 6. So overall, you will get it as 1 by 6 because it's here 1 by 36 and 1 by 6, 6 will go on the top and 6 will cancel the 6 and it will give you 1 by 36. So that's why this is, I would say this is one of the rule for conditional probability.
Is it Bayes theorem?
No, Bayes theorem will come later, yes. Yeah, but we will go to Bayes theorem and Bayes networks. So you can see that A given B equals to A and B divided by B. Now we can rearrange it that if we know what is the probability that A is true given B, and if probability of B, we can easily find what is probability A and B, and vice versa. It means that we can change it and we can go ahead. But here one thing important to see is, if I mention it here, that this equation holds only when your probability of B is non-zero, right? If it is 0, it would be an undefined. And similarly, so you can see that if it is A and A given B, it would be A and B divided by B. On the other hand side, if it is B given A, again it would be P of A and B, or B and A is the same thing, divided by probability of A. So only the denominator changes, but you can see that if we have A given B or if we have B given A, the numerator is the same. It is A and B or B and A is the same thing, and in the denominator, whatever is the given would be the probability, given would be the probability. So now it means that we have these two equations. In other words, so if we define this, in other words, the only way A and B can both be true is, so the only way this can exist is if A is true and we know that B is true given A is true. So it means that B is also true. So these are two very important relationships that we're going to use. But before going further, it's very important to quickly recap what is a random variable. What is a random variable? Yes.
Any discrete or continuous variable.
Mm-hmm.
Any discrete or continuous variable.
It can take any value, right? So we don't know what its value would be, but it is a random variable. For example, we can define a random variable as dice. So dice is a random variable. We can define it as dice. It can take multiple values, right? Similarly, if we talk about weather, it could be sunny, cloudy, rainy, snowy. So it means that it can take different values. Then traffic, it could be none, light or heavy, Then flight, it could be on time, delayed, cancelled. If it is temperature, it could be below 50, 50, 70, 80, and so on. So it means that this is a random, all this we can define as random variable, but now to each random variable, there would be an associated probability, right? So getting 1, there would be some probability, getting 2 would be something. Similarly, if it is sunny, based on whatever, we don't know, but we can define certain probabilities. Temperature would be below 50, we can define based on certain knowledge, based on certain data, we can see how the temperature was changing. If over the year, how much time the temperature was 50, and then we can define the probability, right? But one important thing to see here is that the sum of probabilities would always be 1, whatever random variable you have. So that's why from here we come to probability distribution. Probability distribution is assigning the probability to each instance. For example, how much time weather was 50. But if, for example, we talk about flight, so probability of flight on time is 0.6, probability of delayed is 0.3, and cancelled is 0.1. If we sum all of them, it should be 1 because there is no other case. So in this case, if we say that what would be the probability distribution, that how it is distributed each of them, we'll define it with a bold P. Here you can see that it is small p, so bold P means a vector, it has many values. So 0.6 would belong to on time, 0.3 to delayed, and 0.1 to cancelled. Similarly, if we talk about temperature, so you can see that here we have defined different probabilities for temperature, and again the sum of probability distribution function is always equal to 1. Okay, now coming to another important rule, where we say that what is P probability of A and B in terms of conditional probability, right? So we say that if A and B are related to each other, for example, if I say that if it's cloudy and then it will rain, or what is the probability that it will rain today given that yesterday it was cloudy? So yes, they are related to each other. But if there are two events which are not related to each other, if for example I say that what is the probability that I will throw dice and I will get 1 given that yesterday was raining, they are not related to each other, right? There is no relation with them. So when there is no relation with them, this relationship changes to a new form, which is P and B is simply probability of A times probability of B. So like I said that if I am saying that I am rolling a dice, what is probability that I will get 1? Because given that yesterday was raining. So they are completely different scenarios. So it means that the probability of getting them both together would be equal to probability of 1 times the probability of other. So here instead of writing this given, we will simply that probability of A and B is equal to probability of A and probability of B. And this will happen only when we have independent variables. For example, wet and rainy, yes, they are not independent, they are dependent actually. But wet and Joy made a joke, they are pretty far away from dependency. So that's why in this case, outside is wet and Joy made a joke. So to find their combined probability and what is the probability that both will happen would be equal to probability of 1 times the probability of 6. Now in this case, this is another example, for example, that in one of the cases we said, what is the probability that I will get sum as 12 given that one of the dice is 6. That was a dependent scenario. But in this case, I'm not saying any dependent scenario. I'm saying that what is probability that I will get this and this. So these are, in this case, these are independent. So that's why it would be simply probability of 6 and probability of 6, A and B. So that's why it's very important that we know what is, if in case we have independent variables, then we can simply go with the normal scenario. Now, here is an example. I want you to solve few things. A lunar lander crashes somewhere in your town. One of the cells is random in the grid. The crash point is uniformly random. The probability is uniformly distributed, meaning each location has equal probability of being the crash. D is the event that it crashes downtown, R is the event that it crashes in the river.
Okay.
Right? Okay. So now you have given the grid that D is the probability that it will crash downtown or in the river, and the probability that it will downtown and river is dr. So the very first thing is, what is the probability of that it will crash in river based on given data?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 plus both, 12, 13, 14, 15, 16, 18, is it?
Yes, 18 would be on top.
Yeah. Then we gotta times, isn't it?
What would be in the denominator?
So it's gonna be we're gonna times it.
Total events, like,
Sorry?
total events.
The total
Yeah,
times.
total events, how much?
Total
Yeah.
for
So you
that.
see it was 6 times 6, right?
Yeah,
How much here?
36.
How much here?
No, here,
Yes,
18.
54. So you
You
have
counted, yeah, so.
6 here and you have
9.
9 here. So it would be,
54, yeah.
yes, good. So it means that the probability that it will crash in the river is 18 by 54. What would be this one?
You count the D's and then.
Yes, how much are these?
6 by.
It's gonna be 3, 6,
Six.
8, 9, 10, 11, 12.
Yeah, so you have 12 because you need, when you're looking at, we'll see a bit further as well, that when you have D at multiple locations, whether combined or not, in order to calculate D, you have to consider all the D, irrespective if they are with R or not. We'll see it in a while with the rules of probability. What is this one?
Is multiplication of.
It's gonna be
P and PD.
6 is between both, right? B and R. D town and the river. Because 6 is it?
Can you simply multiply them?
I think it's like mutual, not mutual, it's mutually exclusive, so we have to use the last
Yes,
one.
so they are not
Yeah.
independent. So
We have
yeah.
to just.
Or you can count them. You know that when they are together, right?
6 is it? 6.
Yeah, so it would be
6.
6 by 54. What is this one?
We have to use
One
the
second.
additional rule, so.
So the probability of getting R was to count R, was D to count D, and was to see them together. What is probability here? So
No, none,
in this
none.
case we know that.
Or is it?
So
So
it's
is
P
PR plus PD minus PDR.
and R divided by.
P or
This was the formula that we have learned, right?
This
Probability of
1 by 3.
given, yeah. So this is the formula for conditional probability that what is the probability that D is, what is the probability of D happening given that R is true is equals to probability of D and R
true.
divided by probability of R, right? So we already know what is P of D and R from this one,
Which is
and
6.
we already know for P or this one. So if you calculate them, you will get finally it as 6 by 18 or 1 by 3. Right? Yes. Now, who is going to find this one? Probability of that it will crash in or given that D was true.
It's gonna be
1 by
Yes, who going to find it?
Yeah, 1 by 2.
How?
Because we just have to.
He will tell me.
With me.
Yes.
Uh,
You understood this part?
yes.
This?
Yes.
Just
D.
count them, right?
Yeah.
And then D and R, just count D R together. Then probability D given R. We just learned conditional probability that it is equals to n of this divided by the second one's probability.
Yeah.
We already have n, right?
Yes, of course.
We already have probability of R. So we divided them and we get the number as 6 by 18. So in this case, what is the probability now? So here you can see that we said that probability of A given B equals to probability of A and B divided by B, right? Similarly, if we have the second case, which is B given A, it is equals to P of again A and B or B and A divided by probability of A. Yeah, second thing, right?
Yeah.
Okay, so
same way.
now I'll ask you the same question. Yes, what is this now? So this is equals to probability of R and D or D and R
Yeah.
divided by probability of
D.
D. This we already know and this we already know. Right? So if we solve them, you will get it as 6 by 12 or 1 by 2.
What's the probability of either D or R?
Sorry?
What's the probability of either D or R, not both?
Need P,
Either D or either R.
P and R. You will see it in a while. We will learn one more in which, just to answer it, it is probability of A plus probability of B minus probability of A and B. Just take all the probabilities but subtract the one that they will happen together to give you probability of A or B. Okay, so here comes Bayes' rule. Right. So Bayes' rule is basically derived from conditional probability. So we know that P A given B is this one, right? And similarly, the second thing that we know is P B given A is again equals to P A and B divided by P A, right? So it means that the numerator part for both of them is same. So it means that we can somehow rearrange them and equate them, right? So based on the first equation, I can get P and B equals to A given B into B. Similarly, for second case, P A and B equals to P B given A into P of A, right? So both of them are true because A and B and B and A are the same thing. So that's why these sides two are same. So if you equate 1 and 2, you will get this new formula, which is called Bayes' rule. This was actually derived by, I guess he was a British scientist, Bayes. So he derived this, and this is called Bayes' theorem. So in this case, what is the advantage of Bayes' theorem is, if you know one thing, if you know the cause, you can reach to the disease, for example, and if you know the disease, you can reach to the cause. So it's both way, and it is more useful. You will see in few examples in a while that probability of B given A is equals to probability of A given B into probability of B divided by probability of A. So it means that if you know their relationship, and if you know probability of one of them, so it means that we can use Bayes' rule if three of them is known and one is unknown, right? Okay, so now the question is that given clouds in the morning, what is the probability of rain in the afternoon? So how it looks like, it says that given clouds,
Probability of rain.
probability of rain. And if we go to the Bayes rule, while we are going to Bayes rule, we will see few more questions here, but just to define Bayes rule, it means that probability of rain given cloud is equals to cloud given rain into probability of rain divided by probability of clouds. What is other information? Other information is 80% of cloudy afternoon starts with rainy morning. It means that probability of cloud given rain is equals to
80%.
80%, right? Similarly, it says that 40% of days have clouds, cloudy morning. It means that probability of clouds is equals to 40%, right? So it means that from the first information, we got this one, from second we got this one, and then 10% of days have rainy afternoons. So it means that probability of getting rain, we also know this one. And now we can apply Bayes' rule and we can see that now what is the probability that given the morning was cloudy, what is the probability that we will get rain in the evening is 1 to
20%.
yes, 20%. Okay, this you will solve for me. Again, Bayes' rule is useful when we have 3 or 4 parts of equation are given. Just try to solve it and then I will explain. Read it yourself, solve it. No one is writing.
Is it 1 by 5,000?
Sorry?
1 by 5,000? No.
How much is 1 by 5,000?
But
0.0002, something like that. I'm not sure.
It should be 0.02. 0.002.
Yeah, that's what I think.
So it's very important that whenever you read a question, try to whatever are the conditions, try to symbolize them. Represent them with symbols. For example, patient has meningitis, hedge,
it's
and patient
50%.
has stiff neck. You define it with E. Sorry.
The people who got the stiff neck and it's 50% of such cases. But yeah. It's gonna be 1 over 5,000. Okay, 50,000.
So it says that in this example, a doctor knows that meningitis causes stiff neck.
It's
Okay.
50%.
So it means the probability of being stiff neck given
It's 50%.
One
is
over.
50%, 0.5, right?
Yeah.
Okay. Good.
And then what's the prior probability of having meningitis is this, so we know that
Is
probability
one
of
over.
50,000.
H is 1 over 50,000 and probability of patient having stiff neck is
1 over 20.
1 divided by 20.
So we
Right? So it's
Yeah, just
Very
yeah, it's converted to okay.
so even in exam you get something similar. You need to define symbols and you need to define what are the conditions. And normally, if for example, if you have this question in the exam, let's say, right, you definitely need to write these first and then put it in the formula, right?
Mm-hmm.
But you will see that maybe normally what I prefer in exam, even for writing these, I set some marks. For example, if you have to draw a diagram to find the answer, so I write that, draw the diagram and set some marks just to give some extra marks. So if you get something question and you are asked different, so you have to define all the things and then solve it.
Is there any question from probability in the exam?
Yes, there will
So
be.
now we're doing statistics.
Yes, there will be one question from this part. Yeah. And I mean, before you came in, I was talking about knowledge base, and I told them to draw entailments themselves. So I guess those who were here, they draw already some entailments from what I said.
yes, it's also be numerical. Most likely.
It's gonna be practical question, all of us. All
Yes, everything is
It's
numerical.
not going to be like
Okay, which is better. I hate. That's confusing. It's easier to revise.
Right. So it's clear, right? Okay. Now, why is Bayes rule important? So, if we know cloudy morning given rainy afternoons, we can easily calculate what is the probability that rainy morning with cloudy afternoons. Vice versa. Similarly, if we know medical test results given the disease, we can also find the probability of disease given the medical results, and finally some other things as well.
Have you used ChatGPT?
Yes, I did.
How did you feel as someone someone who have some experience on AI? What did you see from that?
It's very good. I mean,
It's very,
sometimes
very powerful because some
Have
answers
you
it
used
gives is so accurate.
GPT-4?
no. Is there another link for that?
No, it's the
Yeah.
same, but you have to pay premium.
No, so if you sign up before, you can access API to use ChatGPT-4, but it's not available for everyone.
I guess I signed up for ChatGPT long time ago, so I'm not sure how to.
And I think we have to pay for that as well.
But it's
They-
very good.
Even the
Even
free one is so powerful. It can code for you.
yeah, I
I
use
mean,
it.
coding is not the most powerful part.
Yeah, I mean, with technical things, it still lacks. I mean, it cannot give you very technical information, but it's
But
very good at writing. I mean, especially now I stopped drafting emails myself. I just tell him something, and ChatGPT drafts it so well. I mean, when I read it, I think I could never have written like this.
Imagine that ChatGPT it's a software now, yeah, it's not a physical part. If we use that software on a hardware part,
On a robot or something,
robot.
what would
And
it
it
do?
will- and
talking to you all day and give him all the instructions to go back to pick up.
And
It's
it
gonna be-
actually going with the plugs in as well, so it would go to your computer, which is a loop. And
You know,
it would execute until we get there.
Amazon at the moment they're using Prophet to pick up the parcel to put in a trace,
Hmm.
right? So it can work 40 hours consistently with non-stop, yes.
Yeah, it will not. He will not go for sleep or anything. Yeah, it's
So
amazing.
it's
Yeah, it's a just machine learning, so it learns every day a lot more than.
Yesterday, my friend,
It's like natural language processing.
he was trying to write a personal statement.
Yeah.
I told him just give him
Yeah,
something.
ChatGPT.
So he told that I did this. My project was in this, and then ChatGPT. Wow, the way.
But the way you ask it is important as well.
Which one
do you
You
use,
have to
the
know
bad
how
one?
to ask it.
Who's
You
that?
have-
Which one do you use, the paid one?
Exactly.
No, the one.
I'm not sure how universities will respond,
But they already blocked it. So.
They already have some.
yeah, you cannot
No,
use it on campus. Yeah.
No. The issue is if you just rely on the ChatGPT to write for you everything, it's not.
No, it's
No.
not. We,
If you
There is a software that checks if it was created by ChatGPT, but it's not 100% accurate.
It's turning.
even if even if you tell ChatGPT, if you give it the paragraph, have you written it? It will tell yes, I have written this. I've tried it.
I think ChatGPT has already implemented something to detect if this is like written.
Yeah.
Yeah, but it's still it's not 100% accurate. I think it has 98% of accuracy, so you can't really use it at university because
Yeah.
you still have that 2% margin.
I'm not sure to what extent it can be limited. Of course, it is very useful. I mean, if you ask him to find, for example, what are the shortcomings in this certain area, it will give you very good information. Yes, I agree with Mohammed that you can use that information, then combine it with some technical knowledge, for example, books or papers or something, and make it attractive. But
Yeah.
completely taking and copying it is
No,
No,
because
even
if for
very
example,
the information will give you is gonna be very dry.
yeah.
It's no give you specific thing if you want, but he will give you just a general knowledge of what he
Yeah.
It's very generic.
for some people they in uni they use it. If they put it as assignment, the Turnitin will pick up because Turnitin got a back end API.
I'm not sure at the moment if Turnitin is able to pick up AI plagiarism, but I've seen one thing because ChatGPT is trained based on internet data, right?
Yeah.
So, I've seen that yes, Turnitin picks up the sources of the lines that it
Yeah.
puts. Yeah.
But even the university Turnitin software they use is just it's not that advanced. I think it's
It's
very
very-
very
It's
limited.
the same from
No, no.
ages, yes.
Yeah, it's very limited. If
But
you-
every university using the same Turnitin, same
It's the
database.
same-
no, it's not the same Turnitin. Maybe they even universities they have different
No,
software.
every university have this Turnitin.
Yes, most of the university they use the same Turnitin, but I've seen few journals they have theirs. If you publish something, then they have maybe different checker, but for university it's the same thing.
All the universities same
I can access the settings and everything. I've never seen any setting change like from past 10-20 years. So.
Yeah, because what I realized, because I use other software to check my Turnitin, and the way the university pick up the Turnitin, the way the other stuff pick up the Turnitin is totally different.
Yeah. That's the, I guess Alessio shared one of link where it was that a complete guide how to use ChatGPT to support your research, but at the
Yeah.
same time it was said that maybe in future there would be some regulation. I guess there should be some,
They should
but I don't know
regulate.
how they're going to limit it. I'm not sure.
But they should limit that. They should implement ChatGPT into the university learning and
Yeah,
teach people how to use it. We
Yeah, I
shouldn't
guess,
limit
yeah.
that.
There should be a course for it, yeah.
because in any way, ChatGPT is like, it gives you all information in one place rather than
Yeah.
navigating. But they should teach you how to use it accurately.
Thank you.
So-
No, do you know Khan Academy? Khan Academy.
Yeah.
Khan Academy, they know they release the software. It's a kind of AI. You can ask a question, will answer you, but the way the design is very fantastic. If you give him the blank question to answer for you, you'll not tell you, no,
Yeah.
I cannot answer for you that, but I can give you a hint. You can use this formula, this and that, try that.
Yeah, but Khan Academy, it actually runs on ChatGPT now, on OpenAI. Also,
No.
as Morgan Stanley, all of them, they do the financial data on the OpenAI. So it is very powerful research, but
Yeah. Let's see how it emerges and how it
we are going very advanced, I think, at the moment.
Yeah, but it means since I used, I heard about it, but I never used it. But since I used it, it's very good. Recently,
Because there's a program bug bounty, like for example, you have to pick up some, misconfiguration of the website and of the ChatGPT. They will pay you if you submit some kind of So last 4 weeks we've been studying how this works, the
Yeah.
behavior of the website and their web application. Well, only they have at the moment the application, web application. They don't have an apps. They haven't released for iOS and Android. That's the web application.
One thing that I've,
Yeah.
I found that ChatGPT is not good at all. If we give you some information and then you ask to provide a reference,
Yeah.
Yeah,
the reference it provides you, it will never take you to that reference. And if then you say this reference is not working, then it will say, oh, maybe only I have access to this reference. So, and ChatGPT is trained up to 2021.
Yeah, you can't. The reference would give you. You can't find on DOI. So
No, you never
It's,
find.
it's very early stage anyway for them. That's what I heard. The
But
guy who designed it.
I think the ChatGPT is better because Google launched their own one. It's called Bard, and Bing as well, Microsoft. But none of them can.
Yeah,
Even come close
obviously,
to-
because ChatGPT has been trained for the past 4 or 5 years, and now,
Yeah.
and the chat from Google and Bing, it's been only up for like 1 year.
Yeah, but they got more data if we put it that
But it
way.
doesn't
If we
matter,
put it
it
that
has-
constant, they
And
got.
it doesn't matter, it has more data.
It does matter. Well, how do you
No,
gonna
ChatGPT
how do you gonna train your how do you gonna
But
train your
ChatGPT
machine
has been up
learning
for
if you
the
don't have
past
any
5
data?
years, that's the point.
Yeah, anyways, yeah, I mean, although Google, I guess Google is most pissed off that why they did
I
not
think
come up with
Google has
something.
something and it cost them money. Something went wrong and they lost like some billion dollars or something like that.
Oh, that's why I stopped.
They had some issue with their, same similar tool, and it cost them money. Like
But ChatGPT,
some mistake it made, and
Microsoft will take it anyway.
Yeah,
They can-
at some point, yes.
Yeah, they will take it anyway.
Anyways, we are going with some more parts with axioms of probability. It says that if you have a probability of something which is true, then the opposite of it would be just subtracted from one, and it will give you the information probability for the other part. For example, if it is cloudy, 0.4. If it is not cloudy, then it will be 0.6. If it rains, and if it doesn't rain. But you can see that these variables are only one variable. But if you have multiple of them combined together, then it would be slightly different case. That's why we, for this case, we go to joint probabilities, because in some cases, or in most of the cases, you cannot say something is true at its own. It means that it is linked with something. For example, if you have rain, it is linked with cloud. If it is not rain, again linked with the cloud. So it means that for such cases, we need to go for joint probabilities. So in case of joint probabilities, we have plenty of options. For example, if I consider only this specific case, you have clouds, you have no clouds. You have rain, you have no rain, right? So it means that in this case, we have possibility of 4 conditional probabilities. So it means that here, if I say that we want to write joint probabilities, P, cloud, comma, rain. So always when you talk about joint probabilities, this is a vector because this is more than one thing. So you have cloud and rain. Now you can see that how many possibilities you have. Cloud and rain, cloud and no rain, no cloud and rain, no cloud and no rain. So it means that overall you have 4 possibilities. That's why if you want to define a joint probability, you define it in this way, but we know that inside it we have 4 possible options. What are the 4 possible options? The first is cloud and rain, cloud and no rain, no cloud and rain, no cloud, no rain. And this comes from the same conditional probability thing, that if you have cloud and rain, it means that probability of cloud given rain into probability of rain. Then probability of cloud given no rain would be equal to probability of cloud given no rain into probability of rain. So it means that if you have such kind of table, if you get some joint probability table, then you can find all these possible options. So it means that if I want to find P rain, we'll go to the next axiom of probability, which will say that if I want to say what is the probability that it will rain, forget about everything now, just look where you have rain. So it means that you have rain here, whether it is cloudy or not. So you will add only rain part. similar to that we did previously, that what is the probability it will crash in river. Same goes if you have no rain, so we will go to no rain. Whether it is cloudy or not cloudy is not for the moment it's important. We will only go for rain. But they will be important when we will say one give another and so on. So in this case we have two rules. One is
Mutually exclusive and one is not mutually exclusive.
exactly. So in this case, if you have P or B, so it means that you get all the probabilities of A happening A, all the probabilities of happening B minus when they happen together. Or, because in this case we are looking for OR case. And then there is another rule which is called marginalization. In this case, like I said, by an example previously, if I want to find what is probability of rain, so it is possible rain with no clouds, rain with clouds. So that's why probability of A is equal to probability of A and B. So comma is equivalent for and plus A and no clouds. So that's why, and same goes for anything. So if you are looking at rain, whatever are the other possibilities, just count all the rains and add them up. So in this case, same goes if I said like, if you want to find probability of x into xi, so simply look for xi and all the other things, whatever are other factors. For example, here there was another factor, something else. So you just need to look at the rain irrespective of the other factors. Similarly, if your xi was no rain, then you only need to look at no rain, because here now you are not considering it. If for example you need to find probability of being cloud, so cloud irrespective of rain or no rain, you need to add this up, and so on. So this gives you the marginalization. And then or when it comes to or, then you will take out. For example, if I say that what is the probability that it will rain or cloud, so you will take all the rains, this one, you will take all the clouds, this one. Now you need to subtract A and B. A and B is the only part, which is 0.08. So it means that if I want to find probability of R, let's say probability of rain or cloud, right? If I want to find this one, so it means that this is probability of rain. What is probability of rain? Rain can happen in both of these cases. So it would be 0.08 plus 0.02 plus second thing is probability of cloud. What is probability of cloud? Probability of cloud is this one, which is 0.08 plus 0.032. And finally, you need to subtract the possibilities of getting both of them, P, A and B. So it means that finally you need to subtract this and this together. So you will subtract minus 0.08 and this will give you the overall exclusive. We'll see some examples as well, which will give you. So who's going to find probability of cloud for me? What is the probability of cloud? You need to use this formula, probability of cloud. So just look for wherever cloud is coming. Only cloud, not cloud. Cloud is here. It doesn't say about rain or no rain. So you will take all the clouds, this plus this. So it would be probability of cloud and rain plus probability of cloud and no rain. Right?
So it's gonna be see if
It's fine, right? Okay, good. Who's going to find the probability of rain? No, probability of no cloud. What is probability of no cloud?
a second.
Point six.
Probability of no color, right? How much? Yes.
Point six.
0.6, just need to add this, right? So that's why it is very important for marginalization and also for the
Exclusion.
exclusive OR, right?
But this is not joint probability, isn't it? It's union probability, if I'm not wrong.
Sorry, tell me again.
This one is union probability, isn't it?
No, I
It's
didn't.
not joint probability, it's union probability.
No, yes, means joint probability, yeah, it's only for single part, yes. If you're asking if it is only for one, but if you're talking about given, one given the other, yes, we'll move it. I mean, we have some more examples, although we don't have time today, but we will move further and we will do some more and we'll try to see how it comes from for the other probabilities, okay? Yeah. In any case, I will share these slides. I have also put some examples in there. We'll see. We'll try to cover it in the next week as well. But just go over it if you like. Okay.
Do you have lab today?
Sorry?
Do you have any lab?
Yeah, we have that.
Is it lab 7? Or goes
It will be last lab.
the pandas, but I think that's the last.
Yeah, this week it is.
Last, you had a lab. Was it lab 6?
Non-pi and pandas.
Yeah.
The pandas, was it lab 5 or lab 6?
Maybe scientific or something, I don't know.
You got complex, then the pandas.
Matplot library. We'll see.
Math probability.
Was it lab?
Matplot library. I will upload to.
Let's go anyway, let's see. Did you do the IHC lab 6? Have you done it? Did you do the last part? Did you use any Arduino Raspberry Pi? The ones that was-
No, you don't have to use any. Just like with this one, with the last part, you just need to do the theory part.
Which one?
You don't have to have Raspberry Pi. to
Yeah,
do
which
it.
one?
Yeah, because in the part in
You just need to install it on your virtual machine.
the virtual machine with the Raspberry Pi and stuff that off that's fine. The health part is asking to use the HPST level.
No, but you don't have to use it because you don't have the hardware
So
part.
so what did you how did you solve it?
I think you just need to answer some
What I love,
questions.
what is
Like
that
even
love
it
for?
says, like it shows you instructions step by step,
Yeah.
and then it says in your notebook.
My notebook is
do
just
that
some
and that.
Jupyter notebook, so.
Yeah,
just
but
try-
I
I'm
didn't-
gonna check, but
Logbook is anything that you are doing.
pretty
I didn't understand that.
Done it,
So,
but it's just
the first part is fine. The last three, last
You know, I would
Once
say,
you read the whole
yeah,
part-
don't worry about logbook too much. Just try to put some because it's just fine.